Good day, everyone. Welcome to another episode of Learn Math with Doc Gilma. Are you ready, guys, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, guys, let's begin. The topic I will be discussing for today's lesson is all about estimating square roots and plotting in a number line. Let's recall perfect squares and their principal positive roots. 0 times 0 is simply equal to 0. So, square root of 0 is equal to 0. 1 times 1 is equal to 1. So, square root of 1 is equal to 1. 2 times 2 is equal to 4. So, square root of 4 is equal to 2. 3 times 3 is equal to 9. So, square root of 9 is equal to 3. 4 times 4 is equal to 16. So, square root of 16 is equal to 4. 5 times 5 is equal to 25. So, square root of 25 is equal to 5. 6 times 6 is equal to 36. So, square root of 36 is equal to 6. So, from here, we have 0, 1, 4, 9, 16, 25, and 36. These are all what we call perfect squares. While 0, 1, 2, 3, 4, 5, 6 are all principal positive roots. So take note of that. Let's recall perfect squares and their principal negative roots. 0 times 0, 0. So square root of 0 is 0. Negative 1 times negative 1 is equal to 1. So square root of 1 is equal to negative 1. Negative 2 times negative 2 is equal to 4. So, square root of 4 is equal to negative 2. Negative 3 times negative 3 is equal to 9. So, square root of 9 is equal to negative 3. Negative 4 times negative 4 is equal to 16. So, square root of 16 is equal to negative 4. Negative 5 times negative 5 is equal to 25. So, square root of 25 is equal to negative 5. Negative 6 times negative 6 is equal to 36. So, square root of 36 is equal to negative 6. From here, we have 0, 1, 4, 9, 16, 25, and 36 are all what we call a perfect squares. While 0, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6 are all principal negative roots. Take note of that. What are perfect squares? When we talk about perfect squares, class, these are numbers whose two factors are the same or equal. Thus, 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and so forth and so on are what we call perfect squares. Now let's have an illustrative example. Approximate the square root of the following irrational numbers to the nearest 10. The first thing you have to do here is to determine what two numbers is square root of 20, guys. So take note, square root of 20 is between square root of 16 and square root of 25. Take square root of 16, which is equal to 4, be the whole number for the square root of 20. Subtract 16 from 20 and take as your numerator. 20 minus 16 is equal to 4. Subtract 16 from 25 and take as your denominator. 25 minus 16 is equal to 9. Divide 4 by 9. So 4 divided by 9. Okay, the quotient is 0.4444. It's a repeating decimal. So therefore, square root of 20 is just equal to 4.444 or simply 4.4. Consider number 2, square root of 50. Take note, class, square root of 50 is between square root of 49 and square root of 64. Take square root of 49, which is equal to 7, be the whole number for the square root of 50. Subtract 49 from 50 and take as your numerator. 50 minus 49 equals 1. Subtract 49 from 64 and take as your denominator. 64 minus 49 equals 15. Divide 1 by 15. So the quotient of 1 over 15 is 0.06666. Therefore, class, square root of 50 is just equal to 7.0666 or approximately equal to 7.1. Consider number 3, illustrative example. Square root of 75. We approximate the square root to the nearest 10. Take note, class, square root of 75 is between square root of 64 and square root of 81. Take square root of 64, which is equal to 8, be the whole number for the square root of 75. Subtract 64 from 75 and take as your numerator. 75 minus 64 is equal to 11. Subtract 64 from 81 and take as your denominator. 81 minus 64 equals 17. Divide 11 by 17. The quotient of 11 over 17 is 0.647058. So therefore, class, square root of 75 is just equal to 8.6470588 or approximately equal to 8.6. We are done with approximation. This time, we're going to plot them in the real number line. Plot the following irrational numbers in the number line. Consider number 1, square root of 20, which is approximately equal to 4.4. Take note, square root of 20 is between square root of 16 and square root of 25. Consider the real number line here, class. Okay, from negative 4 up to positive 10. The first thing we're going to plot here is square root of 16, which is 4. Square root of 25 is 5. So take note, 4.4 is just between 4 and 5. So from here we have 4.4. This is actually the point of square root of 20. Okay. Take note of that. Number 2, square root of 50, which is approximately equal to 7.1. Take note, square root of 50 is between square root of 49 and square root of 64. Consider again the real number line here, class. From negative 4 up to positive 10. The first thing we're going to plot here again is square root of 49, which is 7. Square root of 64 is 8. Take note, square root of 50 lies between 7 and 8. From here we have 7.1, so this is just square root of 50. Okay, let's have number 3. Square root of 75 is approximately equal to 8.6. Take note, square root of 75 is between the square root of 64 and square root of 81. Consider again the real number line here, class. From negative 4 up to positive 10. So the first thing we're going to plot here is square root of 64, which is 8. Square root of 81 is 9. 8.6 is just between 8 and 9, so we have here 8.6, which is square root of 75. Before we end our discussion, let me first read to you a simple passage from the Bible, Philippians 4:13. I can do all things through Christ who strengthens me. Take note, class. Skills are developed through constant correct practice. There will always be a room for improvement. That's all for today, class. See you in the next lesson. Keep safe, everyone, and may God bless us.